class now. In the last class, we took introduction to matrix method. Now in this class, we'll start the module of fifth module, which is stiffness method. Let us share my screen now. Am I audible? Anybody? And my screen is visible to you? Anyone?
Yes, sir.
Okay. Is my screen visible? Is my screen visible to you?
Yes, sir.
Okay. Okay. Now let us start with module 5, which is stiffness method. Stiffness method of matrix stiffness method. So what is stiffness first? We'll give some introduction to this stiffness method, and we'll start with the numerical problem, one numerical problem to this. So what is this stiffness? You have already seen the stiffness in the previous moment distribution, and you have even you have derived the stiffness for cantilever beam and all. So to recall back, so what is stiffness? Stiffness is equal to force divided by displacement. Stiffness is force divided by displacement. That is, if I take stiffness as K matrix, force as P matrix, and displacement as delta, then K is equal to P by delta. Now this K is equal to P by delta, if I take delta is equal to 1, that is displacement is equal to 1, then what I get is, I will get K is equal to P. K is equal to P when delta is equal to 1. What does it mean? Stiffness is directly the force required to give unit displacement. For unit displacement, how much is the force required? That itself is a stiffness. So that what does it mean? Stiffness is a force matrix. Clear? Stiffness is a force matrix. So that means stiffness is defined as force required to produce unit displacement, because your delta is 1. When delta is 1, then only K is equal to P. If not, K is equal to P by delta. So stiffness is defined as force required to produce unit displacement. So that means, example, if I take a cantilever beam, now, sorry, this is a cantilever beam. I apply a force P here. If I apply force P, I will get a displacement as delta. This is AB. Clear? If I apply a force P, I will get displacement delta. Now, if suppose this displacement is equals to 1, if I get the displacement as 1 unit, then this force what I am applying is nothing but the stiffness of this beam. So stiffness of this cantilever beam is stiffness of cantilever beam of this beam is K is equal to P. How much you are applying? So that will be the, how much you are applying, that will be the, how much force you are applying, that will be the stiffness of this beam. So stiffness is defined as a force required to produce unit displacement. Please remember this. Now when K is equal to, stiffness is equal to force by displacement, then the displacement delta is P by K. The stiffness, the displacement delta is P divided by K, or 1 divided by K is nothing but the inverse, K inverse into P. Always you have to take inverse matrix first, then you have to take the next matrix. I cannot take P into K inverse. Clear? So first is the inverse, K inverse into P. So delta is equal to K inverse into P is the equation for determining any unknown displacement. If I know the stiffness matrix and the force, then I can calculate the unknown displacement by stiffness method. So this is delta is equal to K inverse into P. The similar same equation will be using in determining in analyzing the continuous beam. So in this stiffness, what is the takeover here is stiffness is force by displacement. It is defined as a force required to produce unit displacement. Clear? Flexibility is again inverse of this. So flexibility and stiffness are inverse to each other. Delta is equal to K inverse. Clear? So that will take it in flexibility method. Now, right now, your delta is K inverse into P. Now let us solve a simple problem of a continuous beam here. I'll take a beam. You have UDL over this span, which is 60 kilonewton per meter, and I have a point load here in this span. It is 100 kilonewton. It is 1.5, and this is 3 meter. You can just listen to this problem instead of noting it down. I will give you the required material for this problem, or I will just post you the video of the same. Clear? Here. So this is A, this is B, this is C. So it is two span beam now, A, B, C. The very first step is this is nothing but a displacement method. For displacement method, what you require is you require degree of freedom dk. So what is the degree of freedom here is you have a rotation here. Degree of freedom here is you have a rotation here. You have a rotation here. There is no rotation at C. And axial deformation will be 0 because it is rigid structure. Vertical deformation is registered because of the reaction. So you have only rotation at A and rotation at B as unknown value. So let I take this as rotation at A as 1, coordinate 1, rotation at B as coordinate number 2. So this is 1 coordinate is corresponding to, it is theta A, and 2 is corresponding to theta B. Clear? Now this dk is 2 now. What is that 2? It is theta A and theta B. There are two unknown values. Dk is equal to theta and theta B. Now what you have to do is you have to assign the coordinates as shown. So I have named it as coordinate number 1 and coordinate number 2. You can choose any direction. I have taken clockwise direction. So you can take anti-clockwise, whatever you like. So I have assumed it as clockwise now. Clear? The next step is you have to determine the stiffness matrix now. Stiffness matrix K. How to determine the stiffness matrix K is I have a beam. The first column I have to determine first. This is first column of a matrix. Now you have two unknowns, right? One is theta A, another is theta B. Clear? There are two unknowns, means the size of the matrix will be 2 by 2. There are two unknowns, so size of the matrix will be 2 by 2. If it is one unknown, the size of the matrix is 1. If you have three unknowns, the size of the matrix will be 3 by 3. So maximum what you can have is, you can have maximum 3 unknowns. 4 unknowns you cannot solve it manually. So for your syllabus it will be a maximum of 3 unknowns. Clear? Now how to determine the first column? The first column is, you have to give unit displacement at coordinate 1, because it is first column. At coordinate number 1 you have to give unit displacement, and what you have to determine is, you have to determine force produced at all coordinates. Because your stiffness is force required to produce unit displacement. Clear? So you have to you should have unit displacement, and what is the force for that unit displacement is nothing but stiffness. So that means you have to give unit displacement here. Clear? For flexibility you have to give unit force there. Clear? Now remember, you have to give unit displacement here. So how to give that unit displacement? Coordinate number 1, where is coordinate number 1? Coordinate number 1 is at A, it is clockwise. So when I apply a force like this, so the beam will deflect like this. This is the deflection of the beam. The span of AB will deflect, but BC will not deflect. So you have deflection at A and B. Now when it deflects like this, so this is your displacement. This displacement delta is 1. I am giving unit displacement. This displacement is delta 1. You have coordinate number 1 here. Clear? Now what I have to do is, I have to calculate the force developed at 1 and 2. Where is 1? 1 is at A, 2 is at B. Clear? Now how much is the force produced now when you have unit displacement? You can recall back, if you have what is stiffness was. Stiffness was, if you give unit displacement, the force produced is 4 EI by L. You have done it in your moment distribution there. So the force produced at A is 4 EI by L. 4 EI by L is the force produced at A, where you are applying. At other end it will be half in the same direction. This is 4 EI by L, means this will be 2 EI by L in the same direction. Clear? So half of that will be carried over to the B. So if you are applying 4 EI by L, so the next end it will be 2 EI by L. And now what you can do is, now you can calculate the stiffness. Now what is K? First column is K11. First column is K11. First element is K11. What is K11? It is force at 1 due to unit displacement at 1. The first digit, numbering will be where you are calculating the value, and the second is where is the unit displacement. So unit displacement is at 1, right? And you are calculating the force at 1. Clear? So K11. So what is K11 now? K11 is just write these values. K11 is, what is the force required at 1? It is 4 EI by L. What is 4 EI by L? See, 4 EI by L, it is the force produced is clockwise, and applied coordinate is also clockwise. It is in this stiffness method or flexibility method, the sign conventions are not like clockwise positive, anti-clockwise negative. It is not that case. What you have to do is, you have to compare whatever the force produced in the member, you have to compare with the coordinate direction. So the coordinate direction you have assumed it as clockwise. That's why I have taken it as clockwise there. Clear? You can, if you suppose you have assumed it as this as anti-clockwise, and the force is also anti-clockwise, force produced is clockwise, then it will be negative here. So therefore I have assumed it as clockwise here. The force coordinate direction is clockwise. The force produced is also clockwise. Therefore it is plus 4 EI by L. This 4 EI by L is for which member? I am calculating for member AB. It is for member AB. 4 EI by L for member AB. What is that 4 EI by L for member AB? 4 EI by L for member AB is, substitute the values. 4 EI is same here. If it is different 1I, 2I, 3I, you have to substitute that. I 4 EI divided by length of member AB is 3. So you will get it as 1.334 EI. This is K11. Next K21. What is K21? I am calculating at force at coordinate number 2 when the unit displacement is at 1. Still the unit displacement where I have given delta 1 is at 1 only. Clear? So this is first column. This 1 means this will give you the first column. Clear? So what is this K21 now? K21 is, what is the force at 2? Coordinate number 2. Where is coordinate number 2? The coordinate number 2 is at B. So at B, the force produced is 2 EI by L. 2 EI by L. But what is its direction? Its direction is clockwise, right? Now what is the direction of coordinate number 2? The coordinate number 2 is also clockwise. So both are clockwise means it is positive. Clear? So when both are positive, it is clockwise. Substitute. This is for again member AB only. So substitute for member AB. 2 EIL is 3 meter. So 2 EI by 3 will give you 0.667 EI. Correct? So this is the first column, K11, K21 you have got. Now similarly, get the second column. What is that second column? Second column. How to get the second column? Give unit displacement at 2 and determine force at 1 and 2. Clear? What is the figure now? See. What is 2? Where I have to give unit displacement at 2. Where is 2 coordinate? Coordinate number 2 is at B. So if I apply a force like this here at B, clockwise direction at B, so the member connected at B, there are two members B and BC, two members are connected, so both members will deflect in clockwise direction like this. Both members will deflect in clockwise direction. Clear? So this delta is 1. This delta is 1. So what I'm doing is I'm applying unit displacement at B. The coordinate number 2 is clockwise. The member BA and BC will deflect in clockwise. Let that deflection be 1 unit. Now what I have to do is, now I have to calculate the force. Now what is that force? The force at A and B. Where you have applied the force, there the force value is 4 EI by L. This is 4 EI by L, clockwise. Opposite end in the same direction. It is clockwise means opposite end here, it will be clockwise. The force will be half of that. So it is 2 EI by L. Here also you'll get 2 EI by L, but I'm not interested here because there is no coordinate at C. Clear? So I have only coordinate at A and B. So I am interested only at A and B. Clear? Now just equate this. So what is first, next column is, second column is K12. What is K12? Force at 1 due to unit displacement at 2. Clear? Force at 1 due to unit displacement at 2. Our this figure is unit displacement at 2. So I have to calculate force at 1. Where is 1? 1 is at A. This is A. Correct? 1 is at A. Now what is the force at A? It is 2 EI by L. 2 EI by L. What is its direction? It is clockwise. Our coordinate is also clockwise. So that means it will be positive. And this is for member again, this is for member AB. Clear? So if you substitute that, what you get is 0.667 EI. Clear? Next value K22. What is this K22? I am calculating force at 2 due to unit displacement at 2. Still your unit displacement it as 2 and I'm calculating force at 2. So what is that force at 2? 2 is at B. But at B there are two values of forces, 4 EI by L and 4 EI by L, because at B you have two members connected. So both are having forces of 4 EI by L each. So this will be, and both are clockwise and our coordinate 2 is also clockwise. So therefore it is plus 4 EI by L for member AB plus 4 EI by L for member BC, because this 4 EI by L is member for BC. So this is for BC. Now substitute 4 EI by L. 4E into I is I divided by length of the member. You can substitute EI if EI is different for member AB and BC. Accordingly, you can substitute 1I, 2I, whatever is that. What is the length for AB? AB is 3, 4 EI by 3 plus 4 EI by member BC is 4 meter, 4 EI by 4. And if you add these two, you will get it K22 as 2.334 EI. So now you have got all the elements. So what is that element? Therefore, your stiffness matrix K is K11 first column, K21 first column. Second column, K12, K22. You can see this. This is 1, this is 1, this is first column. This is 2, this is 2, this is second column. 1 will be unit displacement at 1, 2 is unit displacement at 2. 1, 2, 1, 2, 2 is the forces at 1 and 2. Clear? So if I substitute that, I can take EI outside. What I get is 1.334 first column, 0.667, 0.667 and 2.334. And if you just see this matrix, this and this element are same. So that means K22, K21 and K22. K21 and K22 are same. K21 equal to K12. See here, K12 1.667, so which is equal to K21. Clear? This is called as law of reciprocal theorem. Clear? You will get same. If you don't get same, then you have gone wrong somewhere. So you can just go back and check. So this is the stiffness matrix that you get it. Now the second next step is you have to calculate the forces. Third step, force locking forces, it is called locking forces. It is P dash. What is this locking forces? You determine the fixed end moments as you determine fixed end moments in the earlier modules. So determine fixed end moments for all the members. You have 100 kilonewton here, you have UDL here, right? This M member will be anti-clockwise, clockwise, anti-clockwise, clockwise. This is MAB, MFAB, MFBA, MFBC, MFCB. Clear? What is the value? This is 100, this is 60. What is the formula? Centrally point load, this is center point load. So fixed end moment is WL by 8. So this is WL by 8. If I substitute WL by 8, W is 100, L is 3 meter divided by 8. This is WL by 8. I will get it as, this is WL by 8. And if it is UDL, it is the fixed end moment developed are WL square by 12, WL square by 12, right? And if you substitute the values, you'll get it as 37.5. This is also 37.5. This is 80. This is also 80. Am I audible and my screen is visible to you? Anyone?
Yes, sir.
Okay. Now you have determined the fixed end moments. So what is this P dash is now? This P dash is the force at coordinate number 1 and 2, fixed end moments at 1 and 2. P dash is fixed end moment, locking forces at 1 and 2. So where is 1 now? 1 coordinate 1 is at A. Coordinate number 1 is at A. Clear? Coordinate number 1 is at A, which is clockwise. So at A, this is coordinate number 1, which is clockwise. Clear? But what is the force produced at 1 now? The force produced, locking force produced at 1 is 37.5. Clear? It is 37.5. But this 37.5 produced is anti-clockwise. Clear? Fixed end moment is first is anti-clockwise, second is clockwise, next anti-clockwise, next clockwise. Clear? So this anti-clockwise 37.5 is anti-clockwise, but the coordinate number 1 which I have assumed was clockwise. So both are different. So therefore it is negative. Clear? If it is if it matches with the coordinate direction, then it is positive. If it doesn't match, it is opposite to the coordinate direction, then it is negative. This is for first one. Now at 2, what is 2? Where is 2? Coordinate number 2 is at B, right? Coordinate number 2 is at B, which is clockwise. Now at B, you have two values, right? MFBA and MFBC. Clockwise is positive and it is not clockwise positive, anti-clockwise negative. If the direction of the force produced is same as that of the direction of the coordinate direction, then it will be positive. If it is opposite, then it is negative. See, this MBA is 37.5, it is clockwise. So our coordinate is also clockwise, so plus 37.5. Right? 80, there are two values, 37.5 and 80. Now this 80 is anti-clockwise, it is at B only, but our coordinate direction is clockwise, so therefore it is minus 80. Clear? So this is the force matrix. How much it will be? It is minus 37.5 and minus 42.5. So this is the force matrix, locking force matrix. Now next is external forces. Next step. External force matrix. This external force matrix is P. Clear? Notice this external force matrix is if the given beam is having external forces along coordinate number 1 and coordinate number 2. Along coordinate 1, that means the coordinate 1 and 2, the forces which we have taken it as rotation, theta A and theta B. So that means the external force should be a couple at 1 and the couple at 2. Clear? But there is no couple, external couple at 1 at A and external couple at B. There is no couple here. Couple means suppose you have 3 kilonewton meter couple at A external force and 2 kilonewton meter at B an external force at B. Then for 1 you have to equate to 2 and for 2 you have to equate 3, like this. So but there are no external forces at 1 and 2. External forces mean you have only 100 kilonewton and 60 kilonewton per meter as the external force over the member. But at the joint, if you have suppose a couple at A and couple at B, 2 kilonewton meter, 3 kilonewton meter like this, then you have to equate this external force to that values. But now right now for this problem, in the next problem, we'll see if suppose there are some external forces, how this external force matrix will be. Now right now the external force matrix is 0. At 1 it is also 0, at 2 it is 0. So our external force matrix is 0. Now next what you have to determine, next step is the unknown displacement. Now we have to determine the unknown displacement delta. What are those unknown displacement delta? At 1, the unknown displacement is theta A. At 2, the unknown displacement is theta B. What are these two? Dk is 2 now. Theta A and theta B. Those are itself the unknown now values. Clear? This is displacement method. We have taken displacement as unknown values. Now these two values you have to determine those unknown values now. How to determine that? You know the equation is delta is equal to K inverse into P force matrix. But this force matrix is, you have external force matrix P and the locking force matrix P dash. So this is the formula. Delta is equal to K inverse into P minus P dash, where P is the external force matrix, P dash is the locking force matrix, that is the fixed end moments. Locking force is the negative of the fixed end moment. So therefore it is negative. I have taken it as here. Clear? So whatever you have determined is the P dash value plus P dash value. Now determine this. Now this value is 0 now. Right now for this P is 0. So your equation will be delta is equal to K inverse into P dash minus of K inverse into P dash, because we have minus here. So P is 0. So delta is minus of K inverse into P dash. Now take those values. K inverse. What is K value? K is EI into it is. Right? Where is that? K is EI into, finally. Where is that matrix? Here it is. So 1, it is EI into the matrix. Now I am taking K inverse means EI will be 1 upon EI. So I will take this as 1 upon EI minus 1 by EI into inverse of the matrix. What is that matrix? 2.334 minus 0.667. Sorry, 6 plus 0.667. 0.667, 0.667, and 1.334. This is the K inverse matrix. K inverse into P dash. What is that P dash? P dash is minus 37.5 and minus 42.5. Clear? So you have to determine inverse now. How to determine inverse of 2 by 2? 2 by 2 inverse matrix is simple. Clear? What you have to do is, this is minus 1 by EI. Sorry, 1 minute. Our matrix is 1.334, 0.667, 0.667, 2.334. This is the matrix, right? I have to take inverse of this. How to determine inverse of this is interchange the principal diagonal elements and change the sign of the other two elements. Clear? What is that? Interchange the principal diagonal elements. 2.334, 1.334. Interchange these two and change the direction of other two elements. These two elements will be same. So minus 0.667, minus 0.667. Right? That divided by this is nothing but the cofactors now. That divided by the determinant A. What is the determinant A? Determinant A is 1.334 into 2.334 minus of this. So it is 1.334 into 2.334 minus 0.667 square into 0.667. Multiply by that P value, P dash value, minus 37.5 minus 42.5. Clear? But don't forget to have this minus sign. Clear? I have seen students neglecting this minus sign. So there is minus sign here. Now simplify this. Clear? How to multiply two matrices? This into this. Right? Divided by the determinant. So if you take that, you'll get the answer as 22.184, 11.88, 1 divided by I. You can practice this, 1 divided by I with sign all. Clear? So that means what are these two values? These two values are this is delta 1, delta 2. What is delta 1? Displacement at 1. Delta 2 is displacement at 2. What is that delta 1? It's theta A. Delta 2 is theta B. So take this EI to this side. EI delta 1 is nothing but EI theta A is 22.184, and EI delta 2 is EI theta B, and how much it is? It is 11.88. If you are getting positive direction means the rotation is clockwise. The rotation is clockwise. Clear? So this is same as that of in case of slope deflection method. You determined the unknown displacement, right? So these are the unknown displacement. Same displacement you get it here. You can take the same problem of slope deflection method and solve it. You'll have the same unknown values here. Clear? Now with this displacement, now what you have to do is you have to determine, our aim is to determine the moments, right? Forces. So by determining the displacement, now you can determine the forces. The last step is the final forces, final moments. So how to determine these final moments? Final moments can be determined by applying the slope deflection equation only. So what is that slope deflection equation? MAB is equal to, if you could recall, it is MAB is equal to MFAB plus 2EI over L into bracket 2 theta A plus theta B minus 3 delta over L. This is the equation. Clear? Now simplify this, substitute the values. MAB. So what is MFAB? We already determined MFAB fixed end moments here. So it was 30 minus 37.5. I have not taken sign here. So it is minus here. It is plus here, minus here, plus here. Clear? But I have compared here only the directions and I have written the values. Right? Now you take clockwise positive, anti-clockwise negative. So MFAB is minus, because it is anti-clockwise, minus 37.5. Clear? Plus 2EI over L. 2EI for member AB, you have to take it. It is I only, divided by length of member AB is 3 into 2 times theta A. 2 times theta A. Theta A value is 22.18. 22.18 plus 1 times theta B, 11.88, and this delta is 0. If you substitute, if you calculate this, you'll get it as 0. And you may get it 0.003, 0.004 because of the decimal points, but it is 0. Why 0? Why you'll get it 0? Our see, our end A is simply supported. Our end A is simply supported means the movement at A will be 0. So you'll get it 0. So this is the check that you can get it. If you get some values 3.5 point something, that means it is wrong. You can just verify. So the next equation is similarly you can calculate other values. MBA. What is that MBA? MFBA plus 2EI over L into bracket 2 times theta B plus 1 times theta A minus 3 delta over L. First alphabet is B, second alphabet is A. So BA, B, A. Clear? Substitute the values. What you get is MFBA is plus 37.5, it is clockwise, plus 2 by 3. This EI you can take it inside, right? EI into theta A, EI into theta B, right? So if you take EI inside, it will be 2 EI theta B. So 2 times EI theta B, 2 times EI theta B, 11.88 plus 1 times theta A, 22.184. If you substitute and calculate, you will get it 68.13 kilonewton meter. Similarly, next span BC, MBC is equal to MFBC, right? MFBC is MFBC plus 2 EI over L into the bracket 2 times theta B plus theta C minus 3 delta over L. If you substitute, it is my MFBC is anti-clockwise minus 80 plus 2 by L. 2 by L, L is 4. EI you can take it inside. 2 EI theta B is 2 into 11.88. Theta C is 0 because there is no displacement. Theta C is 0 and delta is 0. So you'll get it as minus 68.13, same values. If you have some decimal point change, you take it the same value because MBA is equal to MBC. So you'll get it same, kilonewton meter. Right. Lastly, MCB. What is MCB? MFCB plus 2 EI over L into bracket 2 times theta C plus theta B minus 3 delta over L. MFCB is clockwise plus 80, 2 by L, 2 divided by 4, EI 2 EI theta C, 2 into 2, 2 EI, you can take it inside, 2 EI theta C, it is theta C is 0, theta B 11.881 EI theta B, delta is 0. So you'll get it as lastly 85.94 kilonewton meter. So this is the final moment. So these are the final moments for the given continuous beam. So when you get these moments, you can draw the bending moment diagram and calculate the shear forces and calculate the shear force diagram. Clear? So this is the end of the problem. Any doubt in the problem? Anybody? Am I audible? So in the next problem, you'll take next class. In the next class, we'll have another problem wherein we'll take some values of external forces at A and B, and we'll solve those problems. Clear? Any doubt? And this same video, I will just I'll put the link into the Google class. You can refer once and solve. What you do, you just solve this problem, the same, get the answers. If you have any doubt, you can just ask me through WhatsApp and all. Or what you can do is another problem. I'll just give you the question for the next problem, which I will solve you in the next class. But what you can do is you can just try solving this problem so that you'll have the doubts cleared. So the problem is we'll be going to take this problem in the next class. You have UDL at B 20. This is 4 meter. Total is 6 meter. This is 5 meter. And you have another 1.5 meter overhang. And you have a force here, which is 20. Clear? This will be the problem which I am going to solve in the next class. If possible, what you can do is you can solve this problem. Clear? So what a hint to this problem is this overhang you have to take as an external force. It is 20 into 1.5. That is 30 kilonewton meter will be the external force at C. And the unknown values will be theta B and theta C will be the unknown value. Again, it is degree of freedom is 2. Clear? Try solving this problem, the first and the second problem, and we'll take this in the next class. Any doubt? Any doubt? Okay, then. Thank you, everybody. You can exit. Please go through the Google class. I will just post this link of this video. You can just recall this at any time. Thank you.